So today we're going to continue our fun with the fundamental theorem of calculus, but this time it's the second fundamental theorem of calculus. There's actually two of them. The first fundamental theorem of calculus gave us a way to take definite integrals using antiderivatives. Okay. The second fundamental theorem of calculus deals with taking the derivative of an integral. Okay. What I'm going to do is on the next slide is the fundamental theorem of calculus. It's a math sentence that you need to write down. So I want you to write it down, and when everyone at your table has written it down, I want you to talk about why it makes sense. The derivative with respect to x of the integral from a to x of f of t dt equals f of x. Write it down and talk about why this makes sense.
I don't know if the T is including anything. Or no, you're always making X is going to be yeah. You're saying after T is like a different function. Or to just saying f of t on the inside will be a different number than x. It looks like it just really confused the answer.
It's with respect, but limited is with respect to x. Function inside. Yeah, and then you get
That's what I'm saying. How does that work? It's the equation. There you go.
Okay. Some of you are a little weirded out about the t's in there, right?
Yeah.
Okay, why are there t's inside? Well, it's because we have this function and we're integrating from a to x. So we do the antiderivative with respect to t, plug in x, plug in a. Now we have a function in terms of x to take the derivative of. Okay? Why is it just f of x? Why would taking the derivative of the antiderivative give us the function? They're undoing each other, right? The derivative of the antiderivative. Okay? They're going in different ways, so when you put it together, voila. Right? Okay. Now, please do not write this down. I am going to show you why this makes sense. Okay? And instead of using like little f, capital F, all of that stuff, sometimes we don't see that as well. I'm going to use an example. Okay? The derivative of the integral from 3 to x of t cubed plus 1 dt. All right? So, if we were to do the integration, what is the antiderivative of t cubed plus 1?
1/4
Evaluated from 3 to x. Okay. So we have 1/4 x to the 4th plus x minus 1/4 3 to the 4th plus 3. So we're taking the derivative of 1/4 x to the 4th plus x minus a constant. Doesn't really matter. 81/4 plus 3, right? Okay. So do you see how we were in terms of t, we plugged in our limits of integration, 3 to x. Now we're taking the derivative with respect to x. Well, the derivative of this is 4 times 1/4 x cubed plus the derivative of x is 1 plus the derivative of constants are 0. We get x cubed plus 1. Okay? Don't do that every time. That is a waste of time. Instead, all we have to do is please now write down this example. Now all we have to be able to do is we identify that this is the derivative of the integral from a to x, which means these two operations are essentially undoing each other, and we're left with x cubed plus 1. Plug in that x into your function. Let's try that again. Most of the work is coming from writing down the problem.
Can x be like an actual number though?
No, x is going to be x, or some sort of function, which we'll get to here in a moment. Okay? Because, Trevor, if x was a number, we would have an integral from a number to a number, which would give us just a constant value, and then the derivative of that would be 0. So it wouldn't really be exciting. Okay? All right. So the derivative of the integral from 1 to x of e to the t squared dt will give us what? E to the x squared. Okay? Where's the catch? Right? Where's the catch? Okay? It's not a big catch. Write this one down. What's different? It's from x to 7. Okay? Here we have from x to a instead of from a to x. Okay, so we need to think of this as the derivative of negative the integral from 7 to x, sine of t squared dt. And some of you are just going to think about that in your head and automatically go to, well, this is just negative sine of x squared. Okay, some of you may want to write it down. Some of you may want to just think about it in your head. I can be flexible either way. Okay, so that wasn't so bad, right? Just reverse it, okay? Still feel like there could be more, right? Here's our other, I don't want to say roadblock because it's not major, but here's our other variation, I guess would be a good way to describe it. Okay, so what's strange here?
Square root.
Okay. this guy right here. Okay? Instead of from a to x, we have a to a function of x. Okay? That is fine. What we are going to do is instead of writing x cubed plus 1, we need to write whatever the function is, cubed plus 1, and we're taking the derivative of something that technically is a composite function. And when we take the derivative of a composite, we have to use what? Chain rule. Okay, because we're taking the derivative, right? Where u substitution would be if we were taking the integral, right? We're going derivative. The derivative of x cubed is 3x squared. So we have 3x squared times the cubed root of x to the 9th plus 1. No, when we have a power to a power, we multiply the powers. Because they're both powers, Joe. Okay. Oh. Okay, we're going to call this x squared right here. I'm asking you to find the derivative of that guy, so write it down. Cost BT. Written different, but it's still the same problem. We're taking the derivative of an antiderivative, which means we're going to get the function. But what needs to be inside the function? X squared, since this is x squared goes inside of our function. And is that it? Chain rule, multiplied by 2x. Okay, now we're going to kind of not worry about the second fundamental theorem of calculus for a few minutes. We're going to go back to a concept with the first fundamental theorem of calculus. Okay, yes, they're two different concepts, but we're still working with integrals, right? This is really all there is to the second fundamental theorem of calculus, okay? Like I said, most of the work is in writing down the problem, all right? Your assignment tonight is a combination of a worksheet and some bookwork. The worksheet is blank on the back, so my advice would be to just do your bookwork on the back here to save you some space or like some paper in your notebook. I know some of you are getting down to the last part of your notebook. You don't have to do that, but that would just be an option. Okay? Now, the worksheet is going to be based off of differentials with the fundamental theorem of calculus. What do I mean by that? Okay? Go ahead and write this down right here for me. Okay, I'm going to give you about 30 seconds to talk with your pod about how do you think we're going to find f of 3.
Your derivative is 4x, so use the antiderivative, the master function plus c, and you plug in 6 for x equals 0 to find your constant. Maybe
Okay. What are your thoughts? Okay. So if this is the derivative, then you're saying f of x is the antiderivative of 4x dx? Okay, so what would we get?
2x squared plus c, and then c equals 6.
Okay, and so then you're saying, all right, when we plug in 0, we should get 6 based on this initial condition right here. So c is 6. So you're saying, all right, well, we know that f of x is 2x squared plus 6. So obviously, f of 3 is 24. Okay, Mrs. Holman, you have the fundamental theorem of calculus written at the top there. You didn't use that. Okay, because there's another way we can do this problem. This is what we did at the very beginning of the year, right? Okay, and you can do this, no problem. Okay, but let me show you another way that we can do it. And this is especially helpful if it is a problem that we can only integrate with our calculator. Okay, and we will come across that every now and then, especially when we get to the AP test time. We can only integrate using our calculator, which would mean this indefinite integration isn't going to be helpful. Okay, so let's talk about the fundamental theorem of calculus. Okay, we have, did you just write on the original problem? Okay, good. So we have the derivative is 4x. We have information at 0, and we're trying to find f of 3. Okay? Well, we know from the fundamental theorem of calculus that if we take the integral from 0 to 3 of f of x dx, it should equal, well, f prime, it should equal f of 3 minus f of 0. That's what the fundamental theorem of calculus says. Do you agree? So what we can do is we can take the integral from 0 to 3 of 4x dx, and that should equal f of 3, which we don't know, minus f of 0, which is 6. So here we have x squared, 2x squared evaluated from 0 to 3. Well, 2x squared evaluated from 0 to 3 would give us 18. Add that 6 over, f of 3 is 24. Okay? You're still doing what I feel is the same amount of work. You're still making very similar calculations. It's just all in one process, where opposed to the one that we did before was kind of broken up into chunks. Let's find this, then let's find this, then let's find this. Where this is just one straight shot to get to the end. Let's do one more, just so you can see that version one more time. Okay, so we have our derivative, which we know no matter what we would put inside of the integral. But if we're going to use the first fundamental theorem of calculus, what should our limits of integration be? Okay, and really you could probably do it either way, 2 to -1, -1 to 2, but I like them to go in ascending order, so -1 to 2. And if that's how we're going to set it up, we know that this would equal whatever the function is evaluated at 2 minus whatever the function is evaluated at -1. We know that's how it works. All right, so our antiderivative is
X squared minus 2x.
we know f of 2 is 3. Okay, help me out with this calculation over here. The 3 times 2 squared minus 2 to the 4th. This right here, or all together?
Just the first. I think the whole thing together is -21.
So -20 minus 1, -21. We all good with that? Okay, so what I'm going to do, I'm going to add 21 over to, ironically enough, it's 24, and add -1 over, f of -1 is 24. Did not mean for that to happen. Kind of fun. Okay, so this is what I would do if I were you. I'm going to give you your worksheet. I would write the bookwork on it so you don't forget that you also have bookwork. Like at the top, page, blah, 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 blah.